Good day everyone! Welcome to the world of mathematics. So in this video, we will learn important things and those are about pre-calculus and basic calculus. So math is not that hard actually. So don't be discouraged or confused right away because I am here. Teacher Ella will help you understand each lesson in this subject. So without further ado, let's start our discussion.
Okay, so before we start, let's have first our daily reminders. Again, so if you think that you can't understand the lesson because of the phasing, you think it's too fast, then you can pause the video. Then after that, you can proceed again or rewatch the video. Then also, much better if you have your ball pen and paper or notebook with you so that you can easily jot down the important concepts, the formulas that we will going to use in solving problems involving our lesson for today. So let's start. Lesson number 5 is hyperbola. So this is the last conic section that we will going to discuss. So let's have first our objectives. First one is to differentiate standard form and general form of hyperbola. Number 2 is to solve problems involving hyperbola. And number 3 is to show respect to every opinions and belief. So let's have the definition of hyperbola. So hyperbola is the locus points xy on a plane for which the absolute value of the differences from the two distinct fixed point or fixed points called foci is constant. So hyperbola is a curve formed by the intersection of a double right circular cone with a plane that cut both halves of the cone. So as you can see, our hyperbola is just like a mirror image of the parabola. Okay. So let's have the different parts of our hyperbola. So first part is, of course, the center. So center is the middle point of our hyperbola, which is denoted as HK. Now let's proceed to our 2C. So when we say 2C, that's the distance between the foci of our hyperbola. So meaning the distance between the focus 1 and focus 2 of our hyperbola. And as you've noticed, we also have two kinds of hyperbola. First is, this is graphed horizontally. So horizontal hyperbola and also in vertical form. Okay, so each one of the graph will show the parts of hyperbola. Next one is, of course, the foci. So when we say foci, so this is the two fixed points located inside of each curve of our hyperbola. So we have coordinates here, which is this one, and finding the value of C, which is, again, when we say C, that's the distance from the center to the one focus, or the focus 1 or focus 2, which is, we can use the formula C square equals A square plus B square. Next one. Next is the transverse axis. So when we say transverse axis, this is the axis of hyperbola that passes through the foci, center, and vertices of a hyperbola. So transverse axis is denoted as 2A. It's just like the major axis or the counterpart of transverse axis to the other conic section is the major axis. Okay, again, transverse axis is 2A. And when we say conjugate axis, this is the axis wherein this is perpendicular to the transverse axis. So conjugate axis is denoted as 2B. Again, so in this graph, Okay, so in this graph, this is our, okay, wait for a while. Ayan. So in this example or in this graph of a hyperbola, our transverse axis is this one. Okay, it passes through the center, while our conjugate axis is this one, which is perpendicular to our transverse axis. Again, when we say transverse axis, 2A, conjugate axis is 2B. So vertices is, the coordinate of vertices is positive and negative A, comma 0, while the covertices is 0, comma, positive and negative B. When we say transverse axis, the partner of that is the vertices, while conjugate axis, the partner of that is the covertices. Okay? Next one, the latus rectum. So, latus rectum in hyperbola is the line through the focus and parallel to the transverse axis. So, this is again the chord that passes through the focus. So, that's latus rectum. This is latus rectum. This is also latus rectum. And in this graph, this is the latus rectum and this one. Now, let's proceed to the asymptotes. So, asymptotes are the lines that a curve approaches as it heads towards infinity. Okay? Again, this is the line that the curve or the curve of our hyperbola approaches. But always remember that when we say asymptotes, we can approach the line, but we can't intersect it. Okay? So that's asymptote. So we have formulas in finding asymptotes. So when we say formulas, we have more than two. So we have, or more than one. So we have two. The first one is if our transverse axis is horizontal, our formula in finding the asymptote is this one. We have y minus k equals positive negative b over a times x minus h. So don't forget to write this formula. We will use it. Then the second one is if the transverse axis is vertical, we have the formula y minus k equals positive negative a over b times x minus h. The difference between the two is the a and b interchange. So that's the difference between the two, aside from the transverse axis. Okay? So let's have the other formulas that we need to, or other formula. So in finding the eccentricity of our hyperbola, we have the square root of a square plus b square over a. So that's the formula for that. Then, let's have the equation of our hyperbola. So we have also general and standard form, just like the other conic section. So general form is ax squared minus cy squared plus dx plus ey plus f equals 0. Again, the a, c, d, e, f are constant. So let's proceed to standard form. So in standard form, we have center at 0, 0 and center at hk. So we have two equations under center at 0, 0. So we can use this equation, the first equation, x squared over a squared minus y squared over b squared equals 1 if our transverse axis is located at x-axis, while y squared over a squared minus x squared over b squared is equal to 1, we will use this equation if our transverse axis is located at y-axis. So always remember that these two equations can be used if the center is 0, 0. Okay? Now let's proceed to the center at HK. So meaning it can be located at quadrant 1, quadrant 2, quadrant 3, or 4. So the first equation is we have x minus h raised to 2 or x minus h squared all over a squared minus y minus k squared over b squared equals 1. So we can use this equation if the transverse axis is horizontal. Okay? And the last equation is y minus k squared all over a squared minus x minus h squared all over b squared equals 1. We will use this if the transverse axis is vertical. Again, when we say transverse axis, this is the axis that pass through the center and the vertex of the hyperbola. Okay? So let's have problem number 1. So let's try to answer this one. So a hyperbola has center at 1, 1, vertex at 1, 5, and conjugate axis 6. Again, as I've told you from the past lessons, we need to analyze first the problem, then identify all the given. Again, we have the given hyperbola. We have the center at 1, 1, vertex at 1, 5. Then we have the given conjugate axis, which is 6. Again, when we say conjugate axis, this is perpendicular to our transverse axis. Now, let's identify each parts or each part of our hyperbola. So again, our given center 1, 1, vertex is 1, 5. So we will plot the points for us to visualize all the given. Conjugate is 2b. Okay, so 6. Or conjugate axis, that is denoted as 2b, 6. So meaning, this is the distance from covertex 1 to covertex 2. Okay, so therefore, this is the covertex 1 and this is the covertex 2. Then we can say that again, this is our vertex, our first vertex. Then later on, we will find the second vertex. Again, in hyperbola, we have two vertex and two covertex. We have two focus, so don't forget about that. Okay, so first is we need to identify our A, or also known as the distance between the center and the vertex. So we can count the units. So 1, 2, 3, 4. So our A is 4, or the distance between center and vertex is 4. Therefore, the transverse axis is 8, and the other vertex is at 1, comma negative 3. Okay, so in finding the second vertex is, we will just jump 4 units going down. So we have 1, 2, 3, 4. So this is our vertex 2. So this is our vertex 2. Okay. Then the transverse axis is 8. Again, when we say transverse axis, this is the axis that pass through the center. Okay. And the endpoints of this is also known as vertices, which is again the vertex 1 and vertex 2. So let's identify the B. So since we have the given conjugate axis, when we say conjugate axis, this is the um, distance between the covertices or the two covertex. So we will just equate this to, or we will divide both side by 2 so that we can get the value of B. So 2 divided by 2 is, or 2B divided by 2 is B, and 6 divided by 2 is 3. So we have B equals 3. Therefore, the covertices is located at 4, 1, and 2, 1. So how can we say that it's located at 4, 1, and 2, 1? So from the center, we will count 3, left and right. 1, 2, 3. So we can say that this is the covertex. So covertex 1 is 2, 1. So 2. Okay, so this is negative 2. Sorry, we have typographical error here. So this is negative 2, then 1. Then next cover text is we have 4, 1. Okay? Now let's proceed to our C. So we already know the A, the value of A, the value of B. So we can use the formula C square equals A square plus B square for us to determine the value of C. So let's substitute the value of A and B. So A is 4 square or 4, then copy our square, plus the value of B which is 3, then the square. So simplify. 4 square is 16, 3 square is 9, so add 16 and 9. Our C square is 25. So for us to determine the value of C, we will just remove the square of our C here or the exponent by finding the square root of both sides. So the square root of C square is C and the square root of 25 is 5. So we have already C is equal to 5. Again, when we say C, this is the distance from center to focus. Okay? To focus 1 or focus 2. So we have 2C as the distance between the foci. So meaning, if C is 5, then our 2C is 10, or the distance between the foci is 10 units. Okay? So therefore, our foci are located at 1, 6. So 1, 6, that is 1, and 1, negative 4. So let's check if it's really 5 as the distance between center to the focus. So 1, 2, 3, 4, 5. So it's correct. Let's check the other one. 1, 2, 3, 4, 5. Okay? Now let's proceed to number 4. Let's now determine the latus rectum. Again, when we say latus rectum, this is a chord that passes through the focus that is perpendicular to the transverse axis. So we have, in finding the latus rectum, the same formula with the ellipse, we have 2b squared over a. So we will just substitute the value of b and a that we have earlier. So b is 3, a is 4. So 2 times 3 square over 4. So 3 square is 9. Times 2, we have 18. Then divided by 4 or over 4. Simplify, 18 over 4 is 4.5. So the latus rectum is 4.5. Okay? Now let's determine the asymptotes. So in finding the asymptotes, we will use the equation or the formula, which is y minus k equals positive negative ab or a over b times x minus h, because our transverse axis is vertical. Okay, so we will use this equation. Then after that, we will substitute our center. So let's recall our center is located at 1, 1. And also our A earlier is 4. Our B is 3. So let's substitute all the values to our formula. So y minus our k is 1. So minus 1 equals positive negative. Our a is again 4 divided by our b, which is 3, times x minus again our h, 1. Let's simplify. So we have the asymptote y is equal to positive negative 4/3 x or 4/3 x. So the graph of our hyperbola here is like this. And the line or the red lines here will represent the asymptotes. Again, when we say asymptote, this is like a boundary in the hyperbola. So the graph can be okay. Again, the graph can't intersect our asymptote or asymptotes. And determine the standard equation. So let's have number 6. So in determining the standard equation, we will use the equation y minus k square all over a square minus x minus h square all over b square equals 1. So we will use this equation because, again, our transverse axis is vertical. So we will just substitute the value of a and b and also the value of our center, which is, again, this is the center, this is our a, this is our b. So we will just substitute it in the equation. So y minus our k is 1, so minus 1, all over our a is 4, then square, copy the subtraction or the minus, then x minus our h is 1, all over 3 square. Again, 3 is our b. Then copy our exponent 2 equals 1. Next is we need to simplify the denominator since we have exponent here. So therefore, okay, so I forgot. Again, we have a square on both terms. So this is a square. Okay. So 4 square is 16. So we have 16 here as the denominator. Then 3 square is 9. So the final answer, the standard equation or the standard form of our hyperbola is y minus 1, this is a square, equals, or y minus 1 square all over 16 minus x minus 1 square all over 9 equals 1. Okay, now let's proceed to problem number 2. Let's now have again the parts. Let's find the parts and the equation of the given hyperbola. So in this problem number 2, we have given vertices. Okay, vertices. So we have vertex 1, negative 3, 0, and vertex 2, 3, 0, and we have the given b, which is 2. Again, when we say b, this is the distance from the center to co-vertex. Always remember that one. First, again, is to plot the given. So vertex 1 is negative 3, 0. Vertex 2 is positive 3, 0. Then okay, so B can be called a semi-conjugate. So our semi-conjugate is 3. Again, when we say semi-conjugate or B, that's the distance from the center to the co-vertex. So first is we will find the 2A or the distance between the vertices. So in finding the distance between the vertices, we can count the units from vertex 1. So 1, 2, 3, 4, 5, 6 to vertex 2. So we have 6 units. So again, distance between the vertices is 2A. So we will copy 2A. This is the formula in finding transverse axis. Again, 2a is another term for transverse axis. Then equals the units that we already count. So we have 6. Then we'll find the value of a by dividing both sides by 2. So 2a divided by 2 is a, 6 divided by 2 is 3. So this is our transverse axis. Again, transverse axis is 6. And our center is the point of origin, which is 0, 0. Now, number 2, let's identify the 2b or the distance between the co-vertices. So, in number 2, it's easy because we have already the semi-conjugate axis or the b, which is the distance from the center to the co-vertex. So, since b is equal to 3, then we can say that 2b is equal to 6. So 3 times 2 is 6. So we have here, this is our conjugate axis. Then our covertices is, or covertices are 0, 3. We're located at 0, 3 and 0, negative 3. Now, let's proceed to number 3, which is we need to identify the value of c. So in finding the value of c, again, we will use the c squared equals a squared plus b squared formula. So we will just substitute the value of a and b that we have earlier. So our a is 3, our b is the same 3. So 3 squared is 9. So we have 9 plus 9, we have 18. So for us to determine the value of c, we need to remove our exponent here. So we need to find the square root of both sides. So square root of c squared is c, and the square root of 18, 3 is square root of 2. So you can use your calculator if you need to. Okay? So therefore, the foci are located at positive negative 3 square root of 2 comma 0, and the distance between the foci is 6 square root of 2. Ayan. So let's now determine the latus rectum. Again, to determine the latus rectum is we have the formula 2b squared all over a, or 2b squared divided by a. So we will just substitute again the value of a and b to the formula. So 2 times 3 squared over, okay, so we have typo here. So this is 3. Okay. So 3 squared is 9 times 2, 18. Again, this is 3. So 18 divided by 3, that is 6. So we have typo here. So our latus rectum should be 6. Okay. 18 divided by 3 is 6. So sorry for the typographical error. Again, in number 4, the latus rectum is 6, not 4.5. Now, let's proceed to the asymptotes. So, since our transverse axis is horizontal, we will use this formula in getting the asymptote, which is again, we will use the given center, the given value of A, and the given value of B. So, according to our problem, our C or center is at the point of origin. So, that is 0, 0. And our A and B is both 3. So, we will just substitute this one. Again, we have the formula for determining the asymptotes in this problem is y minus k equals positive negative b over a times x minus h. So our k is 0, so y minus 0 equals positive negative 3 as our b divided by our a3 and multiply it to x minus 0. So y minus 0 is y. X minus 0 is x. 3 divided by 3 is 1. So therefore, our asymptotes here eh, are y is equal to positive x and y is equal to negative x. Okay? So this is our asymptotes, the red lines here. Then this is the interpretation or the graph of our hyperbola. So let's have the standard equation. So since again our transverse axis is horizontal, we will use this one. And as you can see, our center is 0, 0. So we will use x squared over a squared minus y squared over b squared equals 1. So we will just substitute again the value of our a and b. So x squared over the value of our a is 3, then square minus y square over 3 square equals 1. So we will just simplify the denominator. 3 square is 9. Then again 3 square is 9. So x square over 9 minus y square over 9 equals 1 is our standard form or standard equation of our given hyperbola.
Hopefully, you really understand our today's lesson. So don't forget to practice more so that you can fully understand our today's lesson. And also, don't forget to attend your synchronous class for more examples and real-life problems about our topic for today. So thank you for listening and see you on the next video. Bye!